here for the International Supercomputing Conference, one of the two major events in the HPC community. There's been an explosion in different workloads, and I think we're all experiencing this generative AI, ChatGPT moment, and that's infusing not just in the commercial space, but also in scientific computing. And that's going to require us to have a diverse set of architectures that can really accelerate that type of work. And Intel's also had a lot of progress in the past year. We've launched 4 new products, our Sapphire Rapids, also known as 4th generation Xeon processor, our Xeon Max CPU with high bandwidth memory, our Gaudi 2 product, as well as our Max GPU. All those are really going to enable a foundation of computing for generative AI and HPC in general. Now on top of that, we need software that can tie it all together, and that's where One API is really getting a lot of momentum in the industry. It's allowing us to support those architectures that we have, plus others in the industry, so it's open, provides choice and compatibility, and not being locked into proprietary solutions. And then finally, we're really working to scale out these systems. The Aurora system, we've delivered over 10,000 blades. Each of those has 2 CPUs, 6 GPUs on them, and this is really getting exciting for us to enable not just some of the key science workloads that are from traditional HPC, but also some of the generative AI that will be used for advancing those technologies. AI Accelerate HPC really talks about the synergistic relationship between AI and traditional HPC. We're seeing more and more AI techniques like hyperparameter optimization, allowing us to reduce the number of iterations or experiments that we need to do for simulations. Conversely, we're seeing a lot of supercomputing designs being applied to large-scale AI systems. So they can learn and have the right level of scalability to be able to have the software that can run across those very large systems. And that's what the HPC community has been doing for decades now. So that's really how those two fit together, and they're accelerating the advances that are happening. From our standpoint, our products, we focus on making sure that we have architectures that allow for very high level performance, which translates either to faster time to solution or lower energy required to do that, which is, we know, so important to really help with climate change, as well as just overall sustainability. So our products are differentiated around their ability to deliver that performance, and we do that through the instruction sets that are implemented, the amount of memory bandwidth that we provide, as well as then the software optimizations that are implemented on top of that. It's not just a piece of silicon, but the real combination of the hardware, software, and the systems that bring them together. One thing that we're excited to showcase is Xeon Max. There's been a lot of growth and performance improvements on compute, driven primarily from core count. So most CPUs have been increasing core count at a very fast rate, but the memory bandwidth hasn't kept up. So we've now created this imbalance in the system where you have all this engine, but you're not feeding it with enough fuel or oxygen to be able to perform as well as it needs to. So with the Max series CPU, we integrate high bandwidth memory into our 4th generation Xeon processor, which then provides a much better balance for those workloads that are memory bandwidth bound. And about 30% of HPC codes are limited because of their memory bandwidth. So by unleashing that memory performance, we get a lot better overall performance of the system. The scalability is fantastic, and it also can compete very well with GPU accelerated implementations by just using the CPU with that high bandwidth memory. I'm also excited to show you our Gaudi 2 product, which is bringing AI dedicated acceleration for both training and inference. And as we see this explosion in large language models and generative AI, it's important to have the most optimized solution for that, and that's exactly what Gaudi provides. And we're showing here is stable diffusion optimization and training across large scale of Gaudi 2 systems. And you can see the number of iterations per second is very high and a very competitive product. I almost feel sometimes difficult to predict what you can do because these really a foundational level of technologies that allow us to generate new capabilities that I don't even know if I'm a good visionary to predict for you. But it will allow us to do a lot of the traditional codes much faster. while also integrating the technologies that we're seeing with AI. And that's really the newness here. And our product designs are really focused around not just focusing on HPC traditional codes or only AI codes, but the intersection of them. And that's, I think, another one of our key differentiators, as opposed to just trying to be a top 500 system, and that's the only thing we care about is getting that high performance impact number, or only caring about AI deployments, because it's really the intersection of using AI for scientific endeavors, and that's where we get the most advances across Earth system modeling, product design, new drug discoveries. All those will be enabled through these technologies.